So in this video, as I had said in the most recent video, I'm going to explain how to do problem number 9. And number 9 is you're being asked, find the values of a and b so that f of x is continuous. Okay, so we've talked a lot about continuity, and so let's go ahead and get started. First thing you should recognize is that all three of the pieces in this piecewise function are polynomial functions. Okay, being that each piece is a polynomial function, all three of these pieces, they're going to be continuous as long as we're within the domain restrictions. Okay, so to the left of -1, so here we have -1 and we go everything to the left. In between -1, not including -1, so we'll include that there. I found this from Lindsay Powley. Great job, Lindsay, on that. She did this on her test, and I thought that was a brilliant idea to show you visually what intervals that we're talking about. Okay, so anyway, left of -1, in between -1 and 2, and then greater than 2 would be everything to the right. So the function f of x is continuous everywhere within these intervals, and the only questionable times and questionable places along the way would be at these transition values. Transition values of -1, +2. Okay, well, let's go through. Let's check x equals -1. Okay, well, at x equals -1, we know that f of -1 would be, we'd put -1 in here, so we get -2 plus a, that's f of -1. Okay, well, what's the limit as x approaches -1? Well, the limit as x approaches -1 from the left of f of x is this. From the left of -1, we use this piece, again, -2 plus a. And then the limit from as x approaches -1 from the right, we see that is from the right would be here, so we use this piece and we plug in -1 in for x, and we get -1 squared is 1, 1 plus 1 is 2. Well, the limit from the left has to equal the limit from the right, so we'd say therefore, that's not a very good therefore, it's supposed to be like that. Therefore, the limit from the left has to equal the limit from the right. Now, don't make the mistake of saying a is 0. Plus 2, and you get a equals 4. So the limit from the left equals the limit from the right. Therefore, the limit is the same as the value of the function. So if a is 4, -2 plus 4 is 2. Okay, so f of -1 is 2. The limit is 2, and everybody's happy. Function is continuous at x equals -1. So we're going to repeat that process here, and maybe after seeing that, maybe you'd want to try the next piece on your own. Okay, so that's the piece that we tried, or we made sure that the function was continuous at x equals -1. Now we do the same thing. X equals, what was that, 2. So x equals 2, we check f of 2. Okay, what is f of 2? We use this piece right here, solid circle, and 2 squared is 4, 4 plus 1 is 5. Okay, so we want to make sure our limit is 5. Okay, well, the limit as x approaches 2 from the left of f of x, well, that's the same piece right there, that's 5. So the limit from the left is 5. We just have to make sure that the limit from the right is equal to 5. Okay, well, what's the limit as x approaches 2 from the right? Well, that's using this bottom piece, because we're approaching 2 from the right hand side, so we're using this piece right here. That means we're going to replace x with 2, so we have b times 2 minus 1, or 2b minus 1, and so we say therefore, so we take this information here just like we did in the last part. Okay, we take this information here and we say therefore the limit from the left, 5, must equal the limit from the right, 2b minus 1. And then you just have to solve for b. Adding 1 to both sides, we get 2b equaling 6, and we know then by dividing both sides by 2 we get b is equal to 3, and we have just found the answer to this problem here, the a value and the b value, so that f of x is continuous. That's it. So the f of x is continuous for all real numbers. Okay, so I think that's good. It's a really good, thorough example there for you to be able to do the other two, 8 and 10. Maybe you couldn't do 8, 9, or 10 in the beginning, but now hopefully you'll be able to do those. We'll talk about those answers in class, and we'll move on to the last page.